What's up, eighth graders? Today we're looking at Unit 4, Week 4, Lesson number 2. And here are our learning targets. Our learning targets says for an equation like 3 times x plus 2 equals 15, I can solve it in two different ways. The next learning target says for equations with more than one way to solve, I can choose the easier way depending on the numbers in the equation. All right, so let's take a moment and I want you to choose two of these problems and solve them. Be ready to share your thinking. So you have card A, which has 100 times x minus 3 equals 1,000. Card B, which has 500 times x minus 3 equals 5,000. Card C, which has 300 times x minus 3 equals 310. Then you have card D, which has 7,200 times x plus 2 equals 7 and 2/10. Pause your video, choose your card. When you're ready, resume the video, and we will go from there. Ready, set, go. All right, welcome back. So let's take a look at card A. So once again, card A was 100 times x minus 3 equals 1,000. So when we are ready to solve this problem, what do you think that we're going to do? What would you do in this instance? You have parentheses in there, right? And we all know that if we follow the order of operations, there's a particular thing that we need to do, right? Yeah. Or there's also another thing that we can do. There's one of these properties that we can use. Does anybody know what this property is called? You are correct. You're going to do the descriptive property. Now, Mr. G, how do I do the descriptive property? Well, it's like this. So you're going to simply take your 100 and multiply it by your x, and then also take that 100 and multiply it by -3. And what do you get in this next instance? Well, you want to get 100 times x minus 300 equals 1,000. Very good. We bring down to 1,000. Now, what do you think we need to do next? So remember, the goal is to get what by itself? That's correct. You said it. We're going to get the variable x by itself. Now, how are we going to do that? Well, if we look at our problem, we can see the constant of -300. So if we want to get rid of that, we have to make a zero pair for -300. And when you make a zero pair for -300, you need to also do that same thing to the right of the equal sign, okay? So in order to make the zero pair, we need to add 300 because we are subtracting 300 now. So when we add 300 on the left, we need to also add 300 on the right. You are correct. Very good. Now here are our zero pairs here. So what happens, it cancels out, and we're left with 100 times x equals 1,300. And how do we get 1,300? Simply by adding 1,300 together. Awesome job. So now we read this particular problem we have now as 100 times x equals 1,300. What operation should we use to get x by itself? You are correct. The inverse of multiplying is to divide. So if we divide, we need to divide both sides by exactly by 100. Very good. And we divide both sides by 100, you're left with a value of x equals 13. Awesome job. Now, do you guys want to check this? Yes, let's go ahead and check it and see. So my original equation, 100 times x minus 3 equals 1,000. What's going to happen in order for me to, oh, 1 second, before we check it, we need to do something else. Now, let's not check it real quick. Let's solve it a different way, okay? So how are we going to solve? What's another way we can solve it? I think that the first time we did descriptive property, maybe this time we can divide. That's correct. Let's go ahead and divide. So when I'm dividing, I am actually going to divide this whole expression here by 100. Yep. And what you do on the left side, you must do on the right side, right? So I'm dividing both of them by 100, and simply I'm going to get this. So I have 100 times x minus 3 divided by 100 equals 1,000 divided by 100. Now, what do you think is going to happen to my 100s on the left side? You're correct. They're going to become 1. Yes. So this is going to cancel and become a 1. And we're left with 1x minus 3 equals, and 1,000 divided by 100 is going to give you what? That's right, 10. All right, 10. And an easy way to show that would be, okay, I have a cross out a 0 here. I can cross out a 0 here. I cross out a 0 here. I can cross out a 0 here, and then 10 divided by 1 is 10. So that's how x minus 3 equals 10. Okay. Now, what's our next thing? We're left with a one-step equation. So if we have some number minus 3 is going to give you 10. Well, how do you solve that? Let's do our zero pairs. And what will we do to make negative 3 become a zero pair? You are correct. You're going to add 3. So we're going to add 3 on both sides. Once again, a negative 3 plus a positive 3 becomes a 0. So we're left with x equals 13. Awesome job. Very good. All right, let's look at card B. So card B, the original equation is 500 times x minus 3 equals 5,000. So what do we do here? Pause the video. I want to see if you can figure out the answer. When you're ready, resume. Ready, set, go. Okay, welcome back. So we're going to do the distributive property first, right? So that means we're going to do 500 times x, and then we're going to do 500 times negative 3. And what we're going to get? We're going to get 500x minus 1,500 equals 5,000. What's the next thing we need to do? You are correct. Add a zero pair. So we're going to add a zero pair to negative 1,500, which will become plus 1,500. We do that on both sides. We know that a negative 1,500 plus a positive 1,500 is going to be a 0. So we're left with 500x equals, and then we add 1,500 to 5,000, and we get 6,500. So 500 times x is equal to 6,500. Now remember, we need to do an operation. So what kind of operation would we do? The inverse of multiplying. And what is the inverse of multiplying? Good job. That's right. So we're going to divide. So let's divide by 500 on both sides of the equal sign. Okay. Divided by 500 on both sides of the equal sign. Okay. And what do we get? Well, we're going to get x is equal to 13. Awesome job. Now let's try the next method by dividing. So we have 500 times x minus 3 equals 5,000. Pause the video. I want you to try to solve it using the division method and see what you come up with. Ready, set, go. All right, welcome back. So once again, we go ahead and divide 500 on both sides, and you'll see that it looks like this. Now, what's going to happen to the 500 on the left? Well, anything divided by itself becomes a 1, right? So we can just cancel that out and make it a 1. Now, because we make it a 1, you don't have to write 1. You can if you want to, but you really don't have to write a 1, okay? And you'll have x minus 3 equals 10 because 5,000 divided by 500 is 10. Awesome job. Okay, so now what are we going to do, Dr. G? Well, not Dr. G, but Mr. G. Okay, we have to get the inverse of negative 3, or should I say get a zero pair of negative 3. And what is a zero pair of negative 3? Positive 3. Good job. So that becomes x minus 3 plus 3 is equal to 10 plus 3. Awesome job. Now, ladies and gentlemen, what's going to happen to this negative 3 and this positive 3 right here? That's right. You guys are intelligent. You remember, it's going to become a zero pair. It comes 0, so it cancels out, right? Get rid of that bad boy. And that leaves us with x equals 13. Awesome job. Now, let's go ahead and check out card C. So we have 0 and 300 times x minus 3 equals 0 and 310. Pause the video, and I want to see if you can solve it by applying the descriptive property. Ready, set, go. All right, welcome back. So now 0 and 300 times x is going to give you what? That's correct. 0 and 300x minus and 0 and 300 times a negative 3 is going to give you what? Yep, a negative 0 and 900. And it's going to be equal to 0 and 310. Very good. So the next thing we need to do is apply the zero pairs, where you just add a positive 0 and 900 to the negative 0 and 900 and do that on both sides. Then what happens here is this cancels out, right? And we're left with 0 and 300 times x is equal to 0 and 3,900. So what do we do next, ladies and germs? That's correct. You're going to divide by 0 and 300s on both sides. So you're left with x equals 13. Well, I'm wondering, could we try it doing a division method? Let's check it out and see. Here we go. So if we use that same original equation and we divide by 0 and 300 on both sides, we're going to be left with x minus 3 equals 10. Now, what do? Add a 0 pair by adding a positive 3 on both sides, and we're left with x equals 13. Now, think about it. Which way did you think was the easiest way to solve this problem? Just think about it for a second. I'll let you decide that on your own. Let's check out card D. For card D, we have 0 and 7200 times x plus 2 equals 7 and 2/10. So 0. Oh, back it up, Mr. G. What did we do? Obviously, we did the distributive property. You're right. Good job. Okay. And once we distribute, what do we get? We get 0 and 7200 times x plus 1 and 4400, and it is equal to 7 and 2/10. Awesome job. The next thing we're going to do is our what? That's right, 0 pairs. It's going to become 0 and 7200 times x plus 1 and 4400 minus 1 and 4400, and it's equal to 7 and 2/10 minus 1 and 4400. Once again, this becomes a 0 pair, and we're left with the following answer. So 0 and 7200 times x equals 5 and 7600. Pause the video and finish solving and see what answer you come up with. Ready, set, go. All right, welcome back. So hopefully when you divide it by 0 and 7200 on both sides, you got the answer of x equals 8. Very good. So now let's check it out using the other method. What are we going to do? The division method. So we're going to just divide both sides by 0 and 7200. What are we going to be left with? We're going to be left with x plus 2 equals 10. All right, and how are we going to solve that? By doing a 0 pair of 2 and negative 2. Remember, the 2 minus 2 is going to become a 0, so that cancels out. So we're left with x equals 8. So just keep in mind which way you thought was the easiest way to do it, because for some cards it was easier to do distributive property, and for the other cards it was easier to divide. So you have to look at them and figure out, what works best for you, because I know what works best for me may not work best for you. Okay, awesome job. So the next thing I want you guys to look at are some work done by 3 of our friends. Okay, and the first one is going to be done by Noah. So let's check out Noah's method. Okay, so the original problem he had is 2 times x minus 9 equals 10. So Noah said he added 9 to each side. So let's look and see exactly what he did. Why do you think Noah added 9 to each side? Yeah, I can understand that, because there's a negative 9 here. He added 9 on both sides. But do you think that's the correct thing to do? No, I don't think so. What should Noah have done first? And this is a question I want you to answer with your teacher, or write it down so you can share with your teacher. Tell us what you think Noah should have done first. Right. Based upon what we just did, I think that he shouldn't have been adding 9 to both sides just yet, because he needs to simplify it first. And he should have did what? That's right. He should have distributed first. That's what he should have done. But because he did not distribute first, it messed his whole entire problem up. Okay? So that's where his mistake came in, right here. Okay? Now let's check Elena's method. So she has the same problem. Elena said apply the distributive property. Okay, Elena, so you might be on to something. So 2 times x gives us 2x, and then 2 times the negative 9 gives us a negative 18 equals 10. Then Elena says subtract 18 from each side. So let's check and see if we're correct. So first we have negative 18 already. So should we subtract 18 on both sides? No, we should do the inverse, and the inverse means to do what? The opposite. So her mistake came in when she subtract 18. She shouldn't be subtracting, she should be adding 18. So therefore, Elena's method doesn't work either. Well, there's always Andre. Let's check out Andre. So Andre has the same problem. First, he says to apply the distributive property, which is exactly what he did, and he did it correctly. Beautiful. Then he said to add 18, so he did that, and that was a mistake that Elena made. She did not add 18, so that's cool. So let's check and see what happens. When he added 18, this became a 0 pair, right? So now we have 2x equals, and 10 plus 18 is 28. Now what are we going to do next? We are going to divide. So the 2x divided by 2 becomes x, and 28 divided by 2 becomes 14. So I think Andre method was the correct one. So how do you feel? Yes. So you guys just became teachers on your own. You didn't even realize it. Look at that. Awesome job. Okay, here we go. So with this problem, 3 times x plus 2 equals 21. So anytime you want to solve an equation in this form, you have a choice to make about how to proceed. You can either divide each side by 3 or you can distribute the 3. So I'm going to let you guys pause the video and take a moment and decide what you're going to do. Either you're going to distribute or divide. And I want you to share your answers with your teacher. Okay? Ready, set, go. All right, here we go. So decide the easiest way to solve. So number 1, you have 2,000 times x minus 0 and 300 equals 6,000. You have number 2, which is 2 times x plus 1 and 2,500 equals 3 and 5/10. Number 3, you have 14 times 4 plus x equals 43. Number 4, negative 10 times x minus 1 and 7/10 equals negative 3. Number 5, 5 and 4/10 equals 0 and 3/10 times x plus 8. So look at all these different options and tell me which one you think would be the easiest thing to do. Okay. Would you be able to divide or distribute? Okay. So which one will we label as divide first? So let's check and see. So looking at that first one, because we have that even number of 2,000 and 6,000, I think it would be easier to divide first. What do you think? Awesome job. So we're going to say number 1 is easier to divide first. So what we're going to do, we're just going to color this one red. So all the ones that's easier to divide first, we're going to color it red. Okay? And then the other ones that are easier to distribute, we just leave them blank. So let's look at the next one, number 2. So would it be easier to divide or distribute? Think about it for a second. Pause the video if you need to, and let me know what you come up with. Ready, set, go. All right. So number 2, it depends on how you really feel, right? Because even if you divided 3.5 by 2, you get 1.75. So it just depends on you and how you really feel. I would probably divide, but I don't know. So I will say it would be pretty easy to divide as well. Number 3, you have 14 times 4 plus x equals 43. So how do you feel about this one, ladies and gentlemen? So just keep in mind, if you divided 43 by 14, will you get a pretty number? Probably not. Probably not, right? So that one, we're going to leave it alone because it might just be easier to just distribute that. Okay? But what about number 4? What happens if we end up dividing, negative 3 by a negative 10? What is that going to do? Yeah, it's going to give us a fraction. So my people that don't like fractions, you probably want to stay away from doing that one, right? That's right. Because it might just make it a little more challenging for you. All right, number 5. What about this one? What could we do easier? Now, this one is written a little bit different, so don't be afraid and don't be confused. So notice that on this side, the variable is on the right and not on the left side, which is fine. So that means whatever you do, you're going to be working with the 0.3 first, right? So if you decided to divide by 0.3, what's going to happen? You think you're going to get a whole number or a decimal? Just think about it. Even if you need to take time to check, go ahead and do that. Pause the video and then resume when you're ready. Okay, so to me, I think it would be easier to divide, and here's why. Because 5 and 4/10 divided by 0 and 3/10 is going to give me 18. So if I can just divide it out, and that makes my life so much easier, and there's less decimals I have to deal with, then I'd rather do that. So I think it would be easier to divide this one first. But like I said, any of these methods depends on you. This is all based on what you want to do because there's more than one way to solve these problems, okay? All right, so here's our sentences. So what are 2 main ways we can approach solving an equation like the ones we saw today? What kinds of things do we look for to decide which approach is better? And how can we check if our answer is a solution to the original equation. All right, so to answer the first one, remember, you can either distribute or you can divide. Okay? The second question, what kinds of things do we look for to decide which one is better? Well, if you know that you can get rid of fractions or if you can get rid of decimals, then you know to do division or whichever way you think will make it easier. Like for an example, if you know that both numbers are even and you feel like dividing will make your life easier, then you go for it. So you look for things like that. Look for even numbers, look for ways to cancel out decimals, look for ways to get rid of fractions. Okay. And how can you check if our answer is a solution to the original equation? Very simple. You can just either do both methods or you can take your answer and plug it back into the equation and solve it to see if you get the original equation. All right? Very good. So let's review our targets once again before we're done. So by now, you should be able to, for an equation like 3 times x plus 2 is 15, you should be able to solve it in 2 different ways. And for an equation with more than one way to solve, you should be able to choose the easier way depending on the numbers and the equation. Ladies and gentlemen, it's been another great day working with you all. I look forward to seeing you in my next video. Have an awesome day.